Vectors is topic number 6 in our Mechanics 1 unit, and we want to understand what is it all about. On page 133, we are told that after completing this chapter, you should be able to use vectors to describe the forces acting on a particle. You should also be able to give the displacement, velocity, or acceleration of a particle as a vector. And as you know, vectors can provide an alternative and most likely a simpler method of solving problems in mechanics. And in everyday life, vectors are used in many situations, and especially where a problem involves movement in 3 dimensions. For example, in computer graphics software, the vectors are used to model the movement of animated characters. Of course, engineers use vectors. They need to consider forces acting in 3 dimensions when they design buildings and bridges and other structures. Under 6.1 and on page 133, we now get to understand what is vectors all about. And on top there, we are told that a vector is a quantity which has both magnitude and direction. And examples of some vectors, and I hope you know some. This is not the first time you're hearing the word vectors, but an example of a vector quantity is velocity, because velocity has the magnitude, which is the speed, and of course the direction. For example, we are moving due north at 20 meters per second. That is velocity. A force is also a vector because it has magnitude and also direction. It could be a horizontal force of 7 newtons. We also have some displacement. We talked about velocity. Velocity is an example of a vector. We have also had force is an example of a vector, and we have had displacement as an example of vectors. All this is just preliminary of what you know, but I want us to just go straight to example 1 and see what we can do, because the question is saying a girl walks 2 kilometers due east from a fixed point O. A girl walks from a fixed point O, let's have our O there. This is due north. To the east, how many kilometers? 2 kilometers. To the east, 2 kilometers. And she's now at point A. This is now point A. And then 3 kilometers due south from A to B. 3 kilometers due south from point A to point B. This is now point B, and this is 3 kilometers due south. Find the total distance walked and describe the displacement of B from O. Describe the displacement of B from O. Now, of course, the distance the girl walks is just a matter of addition, because she walks 2 kilometers due east. This is to the eastern side. This is to the eastern side. And then after reaching point A, after walking for 2 kilometers, she walks 3 kilometers to point B due south. So the total distance walked is 2 plus 3, which is 5 kilometers. The girl walks for 5 kilometers. That is point A of the question. But point B of the question is talking about, is asking us, describe the displacement of B from O. the displacement. Describe the displacement of B from O. We have to talk about two things here. We have to talk about the direction of B from O, and we have to talk how far is B from O. And of course, how far is not as hard because we can see we have formed a right angle triangle OAB with 90 degrees at point A, and therefore we can easily use the Pythagoras theorem, and we can talk about OA easily is the square root of 2 squared plus 3 squared, which is the square root of 4 plus 9, which is the root of 13, which is basically 3.61 kilometers. We can have 3.61 kilometers, although root 13 is the most accurate answer for that. But what is now the direction? The direction of B from O, we must be able to get that bearing. And of course, we know that part of the angle is 90 degrees. So we need to get theta so that we can add to 90 and get the bearing of. But as you can see, with this theta, you can have opposite and adjacent. That means the tangent of theta is 3 out of 2. And theta is the tan inverse of 3 over 2, which is basically 56.3 degrees. So the whole of the bearing of B from O is the whole of this angle, which is the bearing now. The bearing is 90 plus 56, which is 146.3 degrees. So in an attempt to answer that question is that we can say B is 3.61 kilometers from O on a bearing of 146.3 degrees, because we are talking about clockwise. So this is simply how we can describe the position of B in relation to the position of O. All right?